So hello everyone, this is part 6 of chapter Is Matter Around Us Pure? So in this chapter we are going to discuss about suspension and its property, colloidals and their property, some MCQs, some questions and then hot questions. The first topic is suspension. A suspension may be defined as a heterogeneous mixture in which the solid particles are spread throughout the liquid without dissolving it. The suspensions are formed only by those substances which do not dissolve in water. If a particular solid solute which do not dissolve in water will be in their own state in the water. So this substance is known as a suspension. That is, it is a heterogeneous mixture. In this we can differentiate between the solute and the solvent part. For example, we have water. If you mix sand, you can easily separate the difference between sand and water. So this is a boundary between sand and water. This is a suspension. The mixture still has undissolved solid particles settles down at the bottom with some particles still floating. So this is known as suspension. During suspension, the particle settles down as precipitate if the suspension is left undisturbed for some time, and the process of settling of suspension particle under the action of gravity is known as sedimentation. For example, chalk water mixture used for coating walls, that is wall putty, or calcium carbonate mixture used for whitewashing. Muddy water, milk of magnesia, it's a very good solution to reduce down the acidity in our stomach. And other medicines, some paints, etc., are the fine examples of suspension. Properties of suspension. A suspension is a heterogeneous mixture. There are two phases. The solid particle represent one phase and the liquid in which these suspended particles are distributed forms another one. The particle size is more than 100 nanometer, that is zero point 0.7, that is 10 raised to the power minus 7 meter. The particles of suspension can be seen through naked eyes or also seen under the microscope. The particles of suspension are unstable, so after some time they settle down by the influence of gravity when the suspension is kept undisturbed, and these particles are known as precipitate. Colloidal solution. A heterogeneous solution in which the particle size is in between 10 power minus 7 to 10 power minus 5 centimeter, such that the solute particle either dissolve or settle down in a solvent is known as colloidal solution. In colloidal solution, a relatively large suspended particle is known as dispersed phase, and the solvent in which the colloidal particles are suspended are known as a continuous phase or dispersion phase. Examples are milk. Now, essential components of colloidal solution. The first essential component of colloidal solution is dispersed phase. It is known as a discontinuous or inner phase. It consists of discrete particles significantly larger than the ordinary molecules, and in this small particles of solute is diffused in the solvent. You remember in solution we have two phase, solute and solvent. So solute is known as dispersed phase and solvent is known as dispersed medium. So dispersed medium or continuous phase or outer phase, it is a medium in which dispersed phase is present. This continuous of continuity interlinked molecules. In the dispersed medium, the dispersed phase is providing itself a continuity. And the third particle is stabilizing agent. Some of the colloidal particles are stabilized itself, but some require some agents to keep them in a colloidal form. So this is a substance which is used to keep the colloidal particle apart is known as stabilizer. So dispersed phase plus dispersed medium is equal to dispersion system, or what we call them a colloidal solution. Example, each of the two phase consists of a colloidal system. They may be a gas, a liquid, or a solid. For example, in milk, flat globules are dispersed in water. So flat globules are dispersed phase and water is a dispersed medium. Hence, fat globules forms a dispersed phase and water is a dispersion medium. Now, colloidal solution classification. Based on the dispersed phase and dispersed medium, the colloidal solutions are classified in the following. If you have gas as a dispersed phase and liquid is the medium, then we call the solution as a foam. An example of foam is soap lather, whipped cream, soda water, and froth, etc. That is, liquid is mixed in gas and form a foam. Now, solid is mixed in gas, then we call it as a solid foam. For example, cake, bread, pumic stone, lava. These are the examples of solid foam. Now, gas is mixed in liquid. We call it as an aerosol. For example, mist, fog, and clouds. Now, liquid in liquid is known as emulsion. Cream, milk, butter, oil, and water. These are all what? Emulsions. Now, solid is mixed in liquid. We call it as a gel. Curd, cheese, jellies, boot polish, butter. These are the examples of gel, that is solid dispersion medium and liquid dispersion phase. Now, gas mixed in solid, solid aerosol, that is smoke and dust, liquid mixed in solid, that is salts, paint, sulfides, inks, etc. Solid, solid, solid in solid, these are solid salts, example alloys, colored glass, gemstones. So these examples are really important. Just pause your video and write down each and every example. Most of the time, you may be asked the direct questions that what is the mist, or tell the dispersion phase and the dispersion medium of a mist, whether milk is an emulsion or a aerosol, distinguish between them, or what is the dispersion phase and the dispersion medium of a milk. So these type of questions may be asked. These are really important. Just pause it, pause the video and write down each and everything. So next we have characteristics of colloidal solution. We all know that these are the particles which are visible under powerful microscope. The particles of a colloidal solution do not settle down with passage of time. The particles of colloidal solution can easily pass through the filter paper because they are of very small size. The colloidal solution are not transparent but translucent in nature. Particles of colloidal solution scatter light. That is, when strong beam of light is passed through the colloidal solution, the path of light becomes visible, and this is known as Tyndall effect. Now comparing true solution, suspension, and colloidal solution. Nature. True solution is homogeneous in nature, that is, we cannot differentiate between the two solute and the solvent. There is no surface boundary. In suspension, they are heterogeneous, that is, we can separate the two things. And in colloidal solution appears to be homogeneous, but actually they are heterogeneous on microscopic level. Particle size in the true solution is very small, that is less than 1 nanometer, but in case of suspension it is 100 nanometer, and in the case of colloidal it is between 1 nanometer to 100 nanometer. So we can say that colloidal solution is in between the true and the suspension solution. Sedimentation. Particles of true solution do not settle down, they dissolve completely, but in case of suspension after some time they settles down. In case of colloidal they also do not settle down because of their very small size. Diffusion. True solution diffuses quickly, suspension unable to diffuse, but colloidal solution diffuse but in a very slow manner. Visibility. Particles are invisible in true solution. Particles are visible by naked eyes or under microscope in case of suspension. In case of colloidal, particles scatter light and can be observed under ultramicroscope. Now filterability, that is how you can filter or how you can separate out the constituent particles. In case of true solution, the particles easily pass through animal membrane and filter paper, but in case of suspension, they are unable to pass through animal membrane or filter, and in colloidal solution also they pass through the filter paper but not through the animal membrane. Now appearance. True solutions appear to be clear and transparent. Suspensions are opaque, that is they do not allow light to pass through them, and colloidal solutions are translucent because a little bit amount of light can be passed through them. This comparison is very important. So you may be asked differentiate between true solution, suspension, and colloid on the basis of their filterability, appearance, diffusion, sedimentation. Any of the point may be asked in your exam. So just again pause your video, write down each and everything in your notebook. And if you have any doubt, you know that you can WhatsApp me. Now, scattering of light or Tyndall effect. This Tyndall effect is given on the name of the scientist who discovered it or who did this particular experiment, that is Mr. Tyndall. So, if a beam of light is passed through a pure water or a salt solution, we know that the path of light is not visible. But when a beam of light is passed through a colloidal solution, the path of light is totally visible. So this scattering of light is known as Tyndall effect, and the illuminated path is known as Tyndall cone. Tyndall effect is caused due to the scattering of light by the colloidal particle. So if you are asked what is the cause of Tyndall effect, the scattering of light due to the colloidal particle is known as Tyndall effect, and this is because of the colloidal particle size that allows the light to scatter. The true solution do not scatter the light, and hence they do not show the Tyndall effect because the particle size is very small, and hence they do not show any scattering effect, and so as the Tyndall effect. As you can clearly see this figure. So this is a light source. In solutions, you are not able to see any light, any path of light. Light beam is not visible. Example, water. In case of milk, which is example of colloidal solution, beam of light is visible. You can clearly see a beam of light. In case of suspension, that is a flour and water mixture, sand and water mixture, the beam of light is clearly visible. That is, Tyndall effect is visible. The application of colloidal system. These colloidal solution, or you can say colloidal system, are very helpful in our day-to-day life. For example, bleeding from a cut can be immediately stopped by applying the alum and the ferric chloride. They make the blood clot or the blood collides. Medicines in the colloidal form can be easily absorbed by our body. Soap cleans dirty clothes due to formation of colloidal solution known as micelles. Micelles is nothing but a cluster. Delta formation. Delta is formed when a river water comes in contact with sea water for a longer period of time. This is again the application of colloidal solution. Appearance of blue color of sky is again the example of colloidal solution. Now, question. Four substances are thoroughly mixed with water, separated to obtain mixture A, B, C, and D. Some of their properties are given below. The first property, path of beam of light passing through it was visible in A, B, and D. So it means A, B, D are not solution, but it is invisible in C. So it means C is your solution part. On leaving it undisturbed, the particles of a substance settles down in A. So A is a suspension, but not in B, C, and D. C is a true solution. So B and D are collide and A is a suspension. The solute particles are visible to naked eyes in A. Again, in case of suspension, this is a property of suspension. The solute particles are visible, but these are invisible in B, C, and D. That is true solution and the colloidal system. So based on these observations, we need to answer which of the following is the correct about A, B, C, and D. First is A, B, and D are colloid and C is a solution. So from this statement, it is clear that C is going to be the solution. And in your answer, only two A and B are your options. So you can take 50-50 lifeline there. So C and D are neglected. So we have to choose between A and B, which is clear from the first observation. So from the first observation, it is clear that C is going to be the solution. So B and A. Second, on leaving undisturbed, the particles of substance settle down in A. So A is going to be suspension. So A is the suspension, B and D are colloids, and C is the solution. So B is your answer. Now some homework question. So first question is state whether the following statement are true or false. It's a very simple question. Bread is an example of solid form. True or false? Sponge is an example of solid form. False. Bread is an example of solid form or not? It's a homework. Now second question. Which of the following is a sol? Shaving cream, milk, fog, soap solution and hairspray. I'm giving you a hint. Soap solution is a sol. Which of the following will not show Tyndall effect and why? Or the answer is salt solution do not show Tyndall effect because it is a true solution. If you have starch, milk and copper sulfate, will any of these solution will show or not? You have to find out. Fourth question, a mixture of sulfur and carbon disulfide is a heterogeneous mixture and shows Tyndall effect. It's a homogeneous and shows Tyndall effect. It's a heterogeneous and does not show Tyndall effect. It's a homogeneous and does show Tyndall effect. So you have to answer. This is your homework question. So that's all for the today's class. So in the next class, we are going to discuss about a separation technique, some questions and hot questions. If you have any doubt, you can contact on the number 98960 71540. That's all for today. Take care.